Hello. This lecture we're going to discuss databases and data warehouses. We'll explain the difference between traditional file organization and the database approach to managing digital data. We'll explain how relational and object-oriented database management systems are used to construct databases, populate them with data, and manipulate the data to produce information. We'll enumerate the most important features and operations of a relational database, which is the most popular database model. We'll look at how data modeling and design creates a conceptual blueprint of a database, and discuss how databases are used on the web. And then we'll finish up with look at operations that are involved in transferring data from transactional databases to data warehouses. Businesses collect and dissect data for many purposes. Data are stored in a database format for easy access and manipulation. Databases have had a profound impact on business. An entire information industry has been created. Database technology is integrated with the internet, and that has contributed to significantly increased commerce. The traditional file approach is where there is no mechanism for tagging, retrieving, or manipulating data. The database approach provides a powerful mechanism for managing and manipulating data. Some of the shortcomings of the traditional approach are the dependency between a program and the data. There's a lot of data redundancy, and there's little data integrity. Data redundancy is the duplication of data, and data integrity is the accuracy of data. Here's the type of file system that was used in the traditional approach 40 years ago for storing data. And you can see that it has fields that are designated in column headings on a particular record. An entity is an object about which an organization chooses to collect data. And entities include things like people, events, and products. A character is the smallest piece of data, and it's a single letter or a digit. A field is a single piece of information about an entity. It's a characteristic or an attribute of an entity. A record is a collection of related fields, and it's about an entity. A file is a collection of related records. Database fields can hold images, sounds, video, and other like data. A field name allows easy access to the data. A database management system, a DBMS, is a program used to build databases, populate a database with data, manipulate data in a database. And here we see a hierarchy of data. We have the database that consists of multiple files, like a professor file and a student file. Then we have the files themselves that are composed of records, and then the records are composed of attributes or characteristics or fields. A field is composed of a particular domain, like the name DOE, D-O-E. And finally, characters make up the elements of a field attribute. Data sources include transaction processing systems, source data input devices such as RFID and scanners, web and mobile activities, purchased external data, and non-operational transaction data from social media. A query is a message to the database requesting data from specific records or fields. A database must be properly secured. Not everyone should have access to all the data. Users will have different views of the data based on the data that they're allowed to see. A database administrator is the person responsible for managing the database. They set user limits for access to the data in the database, among other responsibilities. Businesses strive to maintain continuous and uninterrupted operations to serve their stakeholders and ultimately to preserve their well-being financially. A backup and redundant storage help ensure continuity of the technology infrastructure. One important concept in databases is the idea of a view, and that's that different people looking at the same table of data will see it differently. For example, there may be an instructor table that HR looks at that has the ID, name, department, and salary. Salary might be considered a private field, and so another user from one of the academic departments might look instead at a faculty view, which is the instructor's ID, name, and department, but without the salary. And again, using different database views, the users have different pictures of the database. A database model is a general logical structure on how the records are stored in the database and how relationships between records have been established. A database models differ in how the records are linked to each other and how users can navigate the database to retrieve records and create records. There's two main models, the relational model and the object-oriented model, and more recently a third model is coming into prominence as well, and that is the NoSQL model. The relational database model consists of tables. It's based on relational algebra. A tuple is a record, an attribute is a field, and a relation is a table of records. To design a relational database, you must understand the entities to be stored in the database and how they relate. Tables are independent of each other, but can be related to each other. A key is a field whose values identify records uniquely, and it's used to uniquely retrieve a record from a table. A join table combines data from two or more tables. A primary key is a field by which records are, again, uniquely identified. Each record in the table must have a unique key value. A composite key is a combination of fields that serve as a primary key. So for example, in the customer table, the customer ID would be an identifier that would uniquely identify each row in a customer table. On the other hand, in the rental table, you would need a composite key. customer ID, and bank ID. And then you could use part of that composite key to look up books via the book ID in the book table. And in turn, you could even get information from the publisher ID in the book table through a lookup to the publisher table. A foreign key is a field that matches to a primary key in another table, and it's used to link the tables, much like a publisher ID in the book table links to a record in the publisher table. There are several types of table relationships. A one-to-many relationship is one item in a table is linked to many items in the other table. A many-to-many relationship is where many items in a table are linked to many items in the other table. So here we see a join table where we have a publisher and a book and title information from the book. The object-oriented database model uses the object-oriented approach for the database structure. Encapsulation combines the storage of data and relevant procedures to process it. It allows an object to be planted in different data sets. Inheritance is the ability to create a new object by replicating the characteristics of an existing parent object. Object-oriented database management systems, or ODBMS, store data objects, not records. So here we see a graphic of an object-oriented database, and you have a set of objects like book, and a book has attributes, book ID, title, publisher ID, edition, and then procedures that you can use with that data. Order a book, add a book, save a book, retrieve a book. A relational operation creates a temporary subset of a table or tables. It's used to create a limited list or a joined table list. Three of the most important relational operators are select, a selection of records based on conditions; project, a selection of certain columns from a table; and join, it combines data from multiple tables to create a temporary table. Structured query language is the language of choice for relational database management systems. Some of its advantages are it's an international standard, it is provided with most relational database management systems, and it has an easy-to-remember, intuitive set of fourth-generation commands. A schema is a plan that describes the structure of the database, including names and sizes of files, identification of primary keys, and relationships. A data dictionary is a repository of information about the data and their organization. Metadata is additional details about the data, source of the data, tables related to the data, field and index information, programs and processes that use the data, and population rules, what can be inserted or updated and how often. So here we see an example of a schema for an employee table in an Access database. And of course, Access is a database system that ships with Microsoft Office. Data modeling. Databases must be carefully planned and designed to meet their business goals. Data modeling is the analysis of an organization's data and the identification of data relationships. It's a proactive process, and it develops a conceptual blueprint of the database. An entity relationship diagram is a graphical representation of all entity relationships. An entity relationship diagram, an ERD, has several components. Boxes identify entities. Lines indicate a relationship between entities. Crossbars indicate mandatory fields. Circles indicate optional. And crow's feet identify many. And so here we see an example of an entity relationship diagram. And then if we look at the professor entity in more detail, we can see the key underlined, professor ID, and then the other attributes of the professor table. The web is dependent on databases. Organizations must link their databases to the web. So there's a need for an interface between the web and an organization's database. This interface may be programmed in one of several web programming languages, such as Java servlets, active server pages, PHP, and web APIs, application programming interfaces. And here we see a graphic of how active server page technology enables web-based queries against a database server. The ASP software talks to the database server, and the ASP software is integrated into the web server. So a data warehouse is a large repository database that supports management decision making. It's typically relational, and data is collected from transactional databases. Data collections that are used for daily transactions are known as transactional databases, and that accumulation of transaction data is useful and is transferred into a data warehouse where it can be analyzed more efficiently. A data mart is a smaller collection of data focusing on a particular subject or department. Transactional databases are not suitable for business analysis because they contain only current, not historical data. A data warehouse requires large storage capacity. Mainframe computers are often used, scalability is an issue, and data warehouses must grow continually. There's 3 phases in data warehousing, setting it up, and that they go by the acronym ETL. And these are the phases in transferring data from a transaction database to a data warehouse. The extraction phase creates files from a transactional database and saves them on the data warehouse server. The transformation phase cleans and modifies the data formats so it's consistent with all the other sources of data feeding into the data warehouse. And then the loading phase transfers files to the data warehouse. A properly built data warehouse becomes a single source for all data required for analysis. Data mining and online analytical processing, OLAP, use data in data warehouses. Managers extract business intelligence for decision making. And here we see the phases in preparing and using a database. We get data from external and internal sources and load it into a data warehouse with the extract, transformation, and load. And then the data warehouse serves OLAP and data mining applications to produce information. So in summary, this lecture we've talked about databases and noted that a database management system is a tool to construct and manage databases efficiently. Relational and object-oriented databases have different advantages. Keys are used to form links between tables or entities. Tables are a collection of records about a type of entity. Primary keys are unique identifiers. Structured query language is an international standard for querying databases. And the database designer creates a schema, which is a roadmap for the database. And database designers conduct data modeling and create entity relationship diagrams by going through the entity relationship modeling process. Pardon me. Many databases are linked to the web, and we finished up with a talk on data warehouses that contain huge collections of historical transaction data, and how we go through a three-phase process to load data into our data warehouse: extraction, transformation, and loading. Big data is a collection and storage of ever more detailed quantities of data. And obviously, the more data you hold, the higher the risk of privacy violations. Thank you.